Hello guys, welcome back to the channel for another Confluent Kafka video. This time we are going to play around with Schema Registry. Okay, so what is Schema Registry and why should we use it? Schema Registry is a repository for managing and validating schemas for topic messages sent from the producer to the consumer. Producers and consumers can use the Schema Registry to ensure data consistency and compatibility as the schemas evolve. Schema Registry is a key component for data governance in Kafka to ensure data quality across teams. For instance, you have a new colleague joining the team and he adds or deletes a new column in the input. It will break everything downstream, right? With Schema Registry and the right compatibility mode, we can eliminate such incidents. Let me share a simple slide of what we are trying to do and then move into a more practical example. Okay, so this is a typical Kafka architecture, right? We have the producer, we have the Kafka cluster, we have the schema registry repository, and we have the consumer. When we use the schema registry, the producer, before sending data to Kafka, talks to the schema registry and checks if there is a schema available there. If there isn't, it registers the schema. If there is, it gets the schema from the schema registry, and what it does is serialize the data with the schema and send it to Kafka in binary format, adding a unique schema ID to the beginning so that the consumer can deserialize the schema ID and validate. So when a consumer processes this message, it will communicate with the schema registry using the schema ID it received from the producer and deserialize it using the same schema. So if there is a schema mismatch, it will throw an error. This is Confluent Kafka. So I have created a trial account. You can do the same, it's free. And what we have to do is actually create a topic. So click on the topics plate here, click on create topic, provide a name, let's say topic 100 with 6 partitions, leave everything as is and create with defaults. Now let's skip this one. So let's not define the schema right now. We will define the schema in the producer in Python. So click on skip and let's create a topic. So that's a new topic. The next step is to get the API keys for the cluster and the schema registry. How can we do that? So click on the client's blade here, wait a few seconds, and then let's create a new client. So click on new client here, select your programming language that you like, Python of course for us, and then here, if you scroll down, you will see the configuration snippet for your clients. Now click on the create Kafka cluster API key and then download and continue. So we want that and create schema registry API key, download and continue. And here, this is actually what we need. So copy that into your notepad or whatever you are using, because here we will need the username and the password for the Kafka producer, for everything here. And then we also need the schema registry URL, right? And the user info. So copy this txt into your notepad and let's move into VS Code. This is the Python code for the producer. Don't worry, it looks daunting, but it's actually very easy. We are going, we will go step by step and explain every step. And let's scroll down here. And as you can see, I have the properties for the producer and for the schema registry here. Instead of, I could use, and the right thing to do is actually use a properties file and load the data from the properties file. But I wanted to use only one screen and not switch between screens and make things easier for the video. So here we need the username, right? So copy and paste the username that we just saw on Confluent Cloud, and here let me get the password as well, and let's paste it here. And now into the schema registry, we have a dictionary. We have to provide 2 parameters, the URL. Let me copy that That's the URL and the basic of user info, right? We also have that from the properties file that we downloaded. Let me paste that here. Okay, so we have the main function, and now let's start creating our producer, right? So first, what we want is the topic name, right? Topic underscore name. The topic that we created is called topic underscore 100. Then we need the schema. So schema, that would be get schema. Let's go into this get schema function, and this is a simple schema defined in JSON. It's a JSON type schema of string type, and here, as you can see, we define the schema. The title is user, the description is demo, whatever, and here is the important thing: the type. It's an object with those properties. The properties contain the columns, the fields. So we will have one field called name, which would be of type string, and the second field age, and that would be of type number. And both those fields would be required as an input when we send this message to Kafka cluster, right? One thing here that it's important is the additional properties is set to true. Now, when you are using JSON, it's not exactly like using Avro or other file format. So when you want to make changes in the existing schema, when you are using JSON, you need to add these additional properties and set it to true. Okay, the next step is to actually create a schema client, right? Schema underscore client, and then we have to call the schema registry client class from the library and provide the schema config. Here is the get schema config function. As you can see, it's just a dictionary with the URL for the registry and the authentication, right? So we have the schema, the topic, the schema client. Now what we need is a key serializer. And let's use string serializer for the key. So default is UTF-8, and then we want a value serializer, and this is the important, the important stuff here. Now we have the JSON serializer. How do we instantiate JSON serializer? We need to provide the schema, right? The schema, this JSON here, the schema here, and then the schema client to connect to the registry, and then we need to provide a function that returns an object into a dictionary. So user to dict. Now this user to dict is just a simple function here that returns a dictionary with the name and the age. So the client is a user of type object. We extend object class, and this is a class for the users, and a user has a name and an age. So, and then we return these properties as a dictionary. And this function, as you can see, it has two parameters. This is for the context serializer. Now, let's scroll down again to the JSON serializer and open the definition. As you can see, it says serializer that outputs JSON encoded data with Confluent Schema Registry framing, right? If you scroll down a bit and you see the arguments, we need to provide the schema, right? The JSON schema definition, the schema registry client instance, and as you can see, to dict here converts an object to a dictionary. Now that's the callable. So if you scroll down again, where it says underscore underscore call underscore underscore, we need to pass, the object and the context serializer. That's why we have when we convert the user into a dictionary. That's why we have the second parameter in our function. It serializes an object to JSON, prepending it with Confluent Schema Registry framing. So this is where we add the schema, this unique ID to the beginning of our message, right? So we need to provide an object instance to serialize, and the serialization contains the metadata relevant to the serialization operation. So let's go back into our code and let's create a producer, just a simple producer, get producer. For this is a simple function that returns the producer here. That's an instance of producer. We provide the bootstrap servers, the protocol, the mechanisms, the username and the password that we got from the properties file that we downloaded. So we create a producer. We have a producer. Now what's next? Start sending messages to the Kafka cluster. So let's use a while true loop, and then in try, let's add an except here, exception, a generic exception. Let's type something. Exception is, let's say, and actually let's break, if there's an exception, break the loop and stop the program, and then add an else statement. We will see what we will do in the else statement if everything goes according to plan, right? Now let's ask for the user to provide a name, right? Let's provide name, and then let's ask the user to provide an age. Input provide age. Perfect. And the age, it's an integer, so let's convert the age into an integer, and let's create a user. So let's instantiate the user class and provide a name and an age. Very simple, right? Let's send a message. So producer.produce, and what we have to pass here is topic. That would be our topic name that we defined up here, right? Topic underscore 100, and then we have to define the key, and that would be key serializer, and just provide, let's say, the name of the user, simple, and the value. Now this is important, value serializer, and now what we have to provide here is actually the object that would be user, right? And then, as you can see, we have to provide serialization context. So serialization context, open brackets, we have to provide the topic name here, and the second thing is the message field dot value to understand that that's the value, not the key. And on delivery, and then what's the name of the function that we have for the callback? Delivery report. So this is a callback function. So if there is not an error, let's print that everything went fine. If there is an error, so if the error is not none, then just print the error, right? That's a callback function, nothing difficult. And here we have the producer, right? Now this is how we can send messages to the Kafka cluster and also provide the schema to the schema registry. Now else, let's say producer dot flash. What producer dot flash does is wait for all the messages in the producer queue to be delivered. So it will block until the previous message has been delivered, which makes the producer synchronous, in other words. Okay, I think we are good to go when it comes to the producer. So let's open the consumer now, and let's scroll down again. As you can see, I have already imported all the necessary libraries. We have, again, a user class, which is an object. We provide the name and the age and dictionary to use. Now this is the other way around. Now from the dictionary we create an object, a user object, right? Before in the producer here we converted an object into a dictionary. Now it's the other way around. We convert the dictionary into a user object. The schema is exactly the same as that, that we have in the producer as well. And here is the configuration for the consumer. So let me take the username and the password that we used in the producer. Here, let's copy that, paste it here, and let's copy the password as well, paste it here. So this consumer here, well, we have to provide the Bootstrap servers, of course, a group ID, just there, create a group ID, give whatever you like here, the offset. So let's get the latest only, not from the beginning, the protocol, the mechanism, the username, and the password. So that's the consumer, pretty easy, right? So let's start by defining the topic name again here. That would be topic underscore 100. Let's get the schema. So schema, let's get schema. Again, the same function, exactly the same function with the same schema. And what we're on now is a JSON deserializer, and then JSON deserializer, right? And then we have to provide two arguments here, the schema, and actually from dict, and that will be dict to user. Again, we provide the function that we created that converts the dictionary into user, and again we need to pass the context serialization here, because if we so click on the JSON deserializer and see what it does. Deserializer for JSON encoding data with Confluent Schema Registry framing. There are two arguments, schema, the schema definition, and from dict when we call the JSON deserializer. As you can see, it converts a dictionary to a Python object instance. You can provide the schema registry client if you want, that's optional. And let's scroll down to the underscore call __. Here we provide the data, the context deserializer, and deserialize a JSON encoded record with Confluent Schema Registry framing to a dictionary or object instance according to from dict if from dict is specified, right? So let's go back to our consumer. Let's define a consumer now. So consumer, and then get consumer config, right? We pass all those this dictionary with all those parameters here to create a consumer. So the consumer has to subscribe to a topic. So let's provide a list of topics, but actually we have only one in our case. And then let's start with a while true loop to run indefinitely, and then add a try and except statement. Come on, except exception, a very generic exception, and let's print something. Exception in consumer is whatever it is, and then break if something goes wrong, and then I'll an else statement. We will see what we will do in that. The first thing we need to do, of course, is start consuming messages. So message, that will be consumer dot call and timeout 1, let's say. If message is none, then continue. So if we don't receive anything, then continue inside the loop. If there is something, now let's get the user. So what do we expect? We expect a user object, right? This is what we sent in our value in the producer here. So here we pass a user. So that's what we have to deserialize now and see the user as it was sent from the producer. User equals JSON deserializer. Let's call the JSON deserializer that we created here. Here what we have to do is pass actually the message value, right? The value that we receive slash the serialization context that we have to pass the topic name, message topic, and we have to pass this message field that would be value, right? Because it's value, it's not the key. So here, let's say we deserialized the user. Let's just print it. So if everything goes according to plan, let's print the user is, let's call user dot underscore underscore dict to see it in a dictionary format, and then outside of the while loop, just let's close the consumer. Let's run the producer now. Python Confluent producer, provide the name, apostolos, right? Provide the names, whatever, and it says your message was successfully produced. If we go into our client here into Confluent Cloud, you will see in the topics the messages. So let me send another message. So let's send one here, provide the name, Jack and age 33, right? And you will see the message here, right? Jack and age. Now, the important thing here is to go under schema and see before we didn't have anything. Now we have a schema for the value, right? And if you click on the three dots, actually if you click on evolve schema, you will see the schema that we defined in the producer, right? With the age and the name, and both fields are required. It's type object, and so here, as you can see now, there was nothing. So the producer registered the schema in the schema registry. That's the case. Now let's go back into our producer and consumer, and let's start the consumer as well. Let me see what we have here. Python Confluent consumer, and let's start also typing more messages, test and age and test 1 2 3 and age, and as you can see it's working fine. We are sending data now to the Kafka cluster, and the consumer consumes the data in real time. Perfect. One thing I like when we define the schema here is that we validate against the input, right? So let's say that for age we remove the int function, so we are going to provide a string, right? But here age is of type number. It expects a number. So if we run, let me run the script, let me run the producer, and let's provide a name, and let's provide an age and type a text, right? As you can see, it validates the input against the schema. So that's pretty cool, because this is the first step. Is something, if something changes in the code, then we also validate this in the first step. Perfect. Okay, now here we are on the Confluent Kafka documentation, and as you can see, there is schema evolution and compatibility section. And here, this is very important about schema evolution, because the compatibility type determines how schema registry compares the new schema with previous version of the schema for a given subject, right? When a schema is first created for a subject, it gets a unique ID and gets a version number. When the schema is updated, it gets a new unique ID and it gets an incremented version number. Now, if you scroll down where it says compatibility types, you can see this table here where it says the Confluent Schema Registry default compatibility type is backward, right? There are plenty of compatibility types. We have the backward, transitive, forward, forward transitive, full, full transitive, and none. So we don't check anything here. All changes are accepted. But if you see the compatibility type backward, the changes allowed here when we have this compatibility type, we can delete fields, and you can see that it's not going to cause any issue. So we are going to delete age and only leave name, right? And this is not going to give us an error if we are using backward compatibility type. If we used, and how can you see the compatibility type? So back to your Confluent Cloud here, as you can see, there is compatibility mode. If you click on this pencil here, the default is backward. If you click on this pencil, you will see the compatibility settings. We have backward, transitive backward, forward, transitive forward, full, etc., etc., and it provides a short description of what all those configuration does, right? So let's use the backward. And what the documentation says about backward is you can delete fields, right? So let's delete the field and see if the schema here will change. So let's say we are going to remove age from the producer, and then it shouldn't give any error. The schema registry shouldn't give any error because it's the compatibility mode is backward. Let's witness that. Back to our producer. So let's remove age here, right? Let's remove that. From the producer, let's remove age from the required fields. As you can see, the additional properties true comes in handy because now we are eliminating one field. And let's actually remove age everywhere from the user. Let's remove that. And where else? We don't need the input here. And let's remove it from here as well. Perfect. And let's go into the consumer. In the consumer, let's remove the age from the object. And here, as we convert, and leave name only. But in the schema, let's remove age from the required fields because now it's not going to exist. But you don't need to remove age as well. So if we save that, and let's run the producer and the consumer again. So running the producer again and provide the name, whatever. As you can see, it successfully only sent the name. Now we don't have age, and here let's run the consumer, provide another name, yep, now it started. It takes a few seconds. As you can see, we can provide the name only. And if we go back into our Confluent Cloud, here you can see the messages. But here, that's the important thing. If you click on Schema Evolution again, you will see this is the new schema that we provided in the producer, right? So we removed dates. Now this is the new schema. Now let's add a new property called wait, right? And let's add the comma here. We have a new property called wait, and it's a number. Right, now if I run the producer, I added this on the producer side. If I run the producer again, now the schema registry is going to validate this version with the previous version, the one that we have on the cloud, and it's going to give us an error. Let's run this and see what we get. Provide the name, whatever. As you can see, it says compatibility backward, right? Exception, schema being registered is incompatible with the earlier schema for subject topic 100, right? And that's because we have compatibility backward. What we have to do is change the compatibility to forward that allow us to add columns. Back to our Confluent documentation, as you can see, back to the compatibility modes, we have backward that we are able to delete fields, and we have forward that allow us to add fields. So let's go into Confluent Cloud, and here we can update the compatibility mode to forward and then add a new column and see what happens, right? Perfect. Of course, before we do that, we need to add this field into our self.wait. That would be wait, come on, and then wait here as well. I think we have to use it as an input as well here. Wait, int, input, provide wait, right? And then pass wait when we create a user object. And I think we are good to go from our producer side. Let me run the producer and see what we get with the new schema and see if it updates the registry. Provide a name, whatever, provide wait. And we successfully sent a new message to our consumer, right? So let's go back into our Confluent Cloud and see what happened to the schema registry. Let's check the evolve schema, and here, as you can see, wait has been added to the schema, and this is the new schema that we provided in the producer. Now we have to add this column in our consumer to consume also the new added column, right? Let's change age to wait here, right? Wait. We have to add it in our object here. Come on, wait, and then also here self.wait equals wait, and then here as well wait. Okay, looks okay to me. And now let's run both the producer and the consumer again with the new updated schema. Okay, I'm running the producer, provide the name, provide wait. Yep, that's fine. Let's run the consumer as well. So let's provide another name. It will take a few seconds for the consumer to connect and start. Let's give it some time. Yeah, as you can see, now we are getting the data, provide the name again, and the producer sends the data with the new updated schema with the added column wait, and this is how you can play with the compatibility mode. This is it, guys. This is for today, just how you could use the schema registry to validate schemas between the producer and the consumer. I believe the compatibility mode, selecting the right compatibility mode, is the most crucial part. If you do not select the compatibility mode, depending on your project's requirements, it will be a mess, because now we have one producer and one consumer and very simple schema. But imagine if you have countless tables and with 100 columns, it could be a disaster selecting the wrong compatibility mode. Overall, with having a schema registry, we ensure that there is an automated way of ensuring data verification and schema evolution, and that the new consumers will not break downstream, right? So that's what is considered good data governance in Kafka. Thank you for watching, guys. I hope you find this video helpful. Please click the like button, leave a comment and subscribe to the channel, and I will see you in the next one. Thank you.